Local minimum? No, it's nothing.
Nothing,
Can't
absolutely nothing. Very
nothing
good.
on the other side.
Absolutely nothing. Excellent. Good. What about this point?
Nothing, because there's nothing on each side.
So I can show the open interval, right? So the function exists left and right, but all of these function values are higher than this. So I agree, it's nothing. Let me stop for a moment and show you an example. What about this point? I'm going to call it point P, A comma B. Is this point a local minimum? Obviously, it cannot be a maximum because these are bigger. But it can or is it a local min?
It appears to be.
Yes, because I can show the open interval where all function values are larger than it. So this becomes a local min. Good. Okay, back to our graph. So that's why this is not the case. What about this point here?
Local minimum?
Local minimum, very good. Is it absolute? No, because there are other values lower than it. Good. Brian already told us that this is the absolute max and local max. Excellent. What about this?
Local minimum?
Very good. What about this?
None.
Careful. Can I show the open interval?
It's a local maximum.
It's a local maximum because the function exists on both sides and function values left and right are smaller than it. So this is a local max. What about this one?
Nothing.
Absolutely. The function is not even defined there. So how can it be no matter what? So that was the analysis. Moving on. I would like us to think in terms of critical numbers now. No, we're not going to sketch the graph. No, we're not there yet. I'm not interested in sketching yet. We're going to sketch everything that we see, a lot. So no, here I just want to find critical numbers and see if they change into max min. Okay, that's more important. We can go back again to our best friend, the piecewise defined function. But what I'm interested in is not graphing. I'm interested in finding critical numbers, if they exist. Or just move directly to this type of problems and find critical numbers. Here we're not asked to graph, we're only asked to find critical numbers. Anyone would like to choose?
38.
Which one?
38.
38. Where are you? 38. Good. So in 38, we have q of t equals t squared plus 9 divided by t squared minus 9. Good. Perfect. So minimum 9 local. Okay. So sorry. Can you do 5? Yes. Yes. Okay. Very good. So now, in order to find critical numbers, remember we have to look at, first of all, we have to find g prime of t and look at g prime of t being 0 and g prime of t being undefined where g of t exists. Can anyone give us the domain of this function, or at least where this function is not defined?
3. 3 and -3.
Very good. Thank you very much. I'm muting you. Please unmute yourselves when you speak. Okay. So indeed, plus or minus 3. This is quadratic. I have to find two solutions. So then I know that the derivative will be undefined at the same points, at the same t values. So I already know that no critical numbers will come from this source because as you know, when we differentiate a ratio, this will stay as is, just it's going to be squared. So obviously, no critical numbers will come from this second source. By the way, the order is not important. You have to determine G prime anyway. So you can look at this and then that, or vice versa. It's not important. As long as you look at both for sure, always. Okay, so our next step is to find G prime. I think it was Q, and I changed it to G. Sorry about that. Okay, G prime of t. Can anyone give us quickly the derivative?
You want it simplified or step by step?
No, just give me the first step for everyone to see.
So do g of t, which is t squared minus, all right, so 2t, which is your derivative of the top times the bottom, which is
Good, excellent.
minus the derivative of the bottom, which is also 2t, times top.
Good. So, of course, I'm going to factor out 2t. I'm trying to get you in the habit of don't multiply. This is not what we want. We always want to factor to simplify our lives here. So then I have t squared minus 9 minus t squared minus 9. So these two go away. Negative 18 times 2, negative 36t divided by t squared minus 9 squared. We had a similar problem on the test, and many of you did not get to the final answer because you're resisting my suggestion. Always factor and simplify. It's always more difficult when you have higher degrees and bigger numbers than when you have factored 2t being a common factor in these two terms, and then look how easy this is now. But again, you have to get into the habit of it. No matter what I say, you have to be convinced that this is better. Okay, so now g prime of t is equals 0. Can anyone give us the answer for g prime of t equals 0? Anyone, please?
0, isn't it?
Very good. A fraction is 0 only when the numerator is 0. Excellent. Now, we determined the critical number. And I know this is not the question. That's it. That's all we were asked to determine. But now I'm going to add the question here. Will t equals 0 become... I don't know what's happening to me tonight. Will t equals 0 become a max min? And the answer is I have no clue. How come? Well, I didn't study the sign of the derivative. I know it's 0. I know it's undefined at negative 3 and 3. I know the domain, the rest is negative infinity to negative 3, union negative 3 to 3, union 3 to infinity. I know the derivative is 0 here. And now I need to study the sign of the derivative. But one piece I refuse to study the sign for, which is the denominator. Why? I'm saying I will never study the sign of the denominator. Why? Anyone?
Because it's always going to be positive.
Of course. I'm not going to waste my time. Excellent. So, and of course, I'm not going to think in terms of 36. Who cares about 36? So the sign will be given by negative t, nothing else. So I'm going to ask you to plug in a number to the left of 0 and tell me the sign of negative t, and I will put it in. And then I would like you to plug in t, any number from 0 to infinity, and tell me the sign of negative t. The rest doesn't count. When it comes to the sign, it doesn't count. So, can anyone tell us before 0?
-1.
One more time. We are discussing the sign of negative t. And we are plugging in a number to the left of 0, not -3 or 3, although you can because you're not plugging in the denominator, plugging in the numerator. And we need the sign of negative t when t is less than 0.
So 1, but
I only want the sign. I don't care about any number. So we are looking at negative t.
So when t is less than 0, then it's 1. Then it's positive.
That's all I want. I don't want any number.
Got it.
Good. Now on the other side. Very good. Excellent. On the other side, what will be the sign?
Negative.
Yes. So then, derivative. Positive means the function is increasing. Derivative 0. And derivative negative means the function is decreasing. What type of point is 0, comma, g of 0? So I can determine g of 0 with no problem. 0, 0, 9 over -9 is -1. What type of point is 0, comma, -1 for this function? Anyone?
Is it like the max?
Very good. It's a local max or relative max. It could be an absolute. I don't care. At this point, I'm only interested in whether it is a max or a min, so at least a local or relative max. Why? The derivative is 0 or undefined, and it changes sign. Because it changes sign in this sequence, positive, negative, it's maximum. If it had changed sign negative, positive, it would have been a minimum. If there is no sign change, this is just a simply critical numbers, it does not become a max min. Good. Do we need another example or we move on? Like to move on? Yes? Say it again.
Can we do another one?
Yes? This was 38.
Maybe 40?
40. Good.
Yeah.
So 40. We have g of x equals the cube root of 4 minus x squared. Can anyone tell us how we determine the domain of this function? If we have to state any restrictions, if we need to write anything to find the domain.
4 minus x squared must be greater than 0.
Yes, yes, only when the index is even. When the index is odd, no problem. Ever. Negative, 0, positive, all work. So it happens that the domain of this function is negative infinity to infinity because the index is odd. But yes, thank you so much. Yes, if this were 4 minus x squared, I would have had to write 4 minus x squared greater than or equal to 0, solve, and get the domain. I completely agree. Thank you. Okay, so in that case, all I have to worry about is find g prime. So first, I will rearrange the function so I can make it easier for myself. Oh, of course, I'm already differentiating in my head. Okay, so the cube root is power 1/3. So now g prime. I bring down 1/3. I subtract 1 from the power. And 1/3 minus 1 is negative 2/3. But then I have to multiply by the inner function prime, which is, can anyone give us the inner function prime?
Minus 2x.
That's it. Thank you very much. So once I rearrange a little bit, which is negative 2x over 3 power negative. Negative power goes to the denominator as the cube root of 4 minus x squared squared. The power is the power here, the numerator is the power, and the denominator is the index. So this is multiplied. Okay. So now we're talking about two sources. So remember, critical numbers can come from either g prime equals 0 or g prime being undefined, where the function is defined. That's why I needed to start with the domain to see where this function is defined, because otherwise I will probably miss a critical number. Who knows? So, can anyone solve this equation for us? G prime of x equals 0. Anyone?
0.
2.
That's it. 0 equals 0. X equals 0. No, 2 cannot be 0. If we had plus or minus here, yes, but this is multiplication. So for 2x, the numerator to be 0, because a fraction is 0 when the numerator is 0. 2x equals 0 means x equals 0. Yes, this is one critical number. Does it become a max min? I don't know. I haven't studied the derivative, the sign of the derivative yet. Okay, is anything coming, is a critical number coming from g prime being undefined? Is this function now, which is different from the original function, is this function ever undefined?
-2.
Thank you very much. Thank you. Indeed. Here I didn't have that problem because this could be 0. If x is 2, I get 0. If x is -2, I get 0. But who cares? 0 is okay. But now that expression is in the denominator. I cannot have 0 in the denominator. So these are one critical number from this source, two critical numbers from this source. Are they max min? No clue yet. I haven't done my work. Haven't tried anything here. So that's why I was so begging you to understand that table, because this is very important now. So g prime of t, g of t, so this is negative infinity to infinity. We know -2, 0, and 2. At 0, the derivative is 0. At plus or minus 2, the derivative is undefined, not the function, the derivative only. And we will determine these values by plugging in. So we already determined them. This is 0 and this is 0. And when I plug in 0 in the original function, I get the cube root of 4, whatever that is. 1 point something. But now I want to study the sign of the derivative. And I have several pieces. 1, 2, 3, 4. The signs in here will tell us what type of points are these. -2, 0. 0, comma, the cube root of 4. 2, comma, 0. Okay, so let's plug in and let's see what we do not want to plug in. Because this is squared and this is 3. I won't spend my precious time on that. So, and forget about 2. So when we plug in a negative number, even if it's -5 or -1, what is the sign of the derivative? I think somebody said positive. Maybe not. I put it in anyway. So to the right-hand side of 0, what is the sign of this expression?
Negative.
Good. So what type of point is -2, comma, 0? Is that a max min? You can say it's a critical number, -2, but is this point -2, 0 a max min?